Hello everyone and welcome in a new video, and in this video we are going to see that what is transmission control protocol TCP. Okay, in this video we are going to understand the whole process of TCP, how the data is basically transferred from each layers, who is responsible for that, and for a particular process what layer is responsible to do so, and different things about that layer, about the TCP, how basically the data is transferred, what are the important terms, what are the combinations of which basically make in this. So we see everything about TCP. Okay, so first of all, TCP means transmission control protocol. TCP means transmission control protocol. Okay, TCP means transmission control protocol. So what is basically TCP do? So TCP is nothing. Here you can see that protocol is written. Protocol means a set of rules or set of some set of things, some set of protocols, some set of rules basically to do something. And in the case TCP, the protocol to sending the data from a source to the destination is simply a transmission control protocol, which basically handle to send the data from sending the files from the source code from the source to destination. What basically going on is files sending files. Okay, TCP, TCP basically work on connection oriented services. Basically TCP follow the connection oriented services. COS, what is COS? Connection oriented services. Now what is connection oriented services? If you don't know about that COS or CIS, then you have to see the videos which also uploaded in my channel, that what is the difference between these two in a very simple way. COS is what? COS first of all make a connection, means connection established between the source and the destination. First of all, what basically happen is in transmission control protocol, connection is made between the source and the destination. Okay, this is step number one. Step number two is sending the data, means data transfer. Sending the data means data transfer. And the third step is after the send all the data files from to destination, then it break the connection means termination connection termination. Okay, so these are the COS, connection oriented services, and TCP follow connection oriented services. Okay, so this is a basic overview of COS. You have if you want to know in detail about COS and CIS, connectionless services, then you simply watch the video, which is the link of that video is in a description box. Okay, now we see the things now. Okay, so in TCP, how the data is transferred from the source to destination. Let's understand this thing. First of all, what we have is a message. Suppose that we have a message. Okay, this is a message. Okay, which is in a sender send. What it have to what basically the sender do is sender send the data. Sender send this message to the receiver. Sender have to send this message to the receiver. Sender cannot send the message directly to the receiver without means if this is the whole message, sender cannot able to send this message directly to the receiver. Okay, sender cannot send the message directly to the receiver. So how basically it's sent in TCP? In TCP, sender, this is the message which is in a sender send. What basically it do? It break the message. It break the message into data units. And there are so many data units. For example, this is one data unit, 2, 3, 4. So the what basically the TCP do is whatever the message that the sender want to send, it break that message into some data units. It break that message into data units. These data unit is also called segment. These data unit is also called segment. This is a very important term that you need to remember, because when we see about UDP, user datagram protocol, which is a different, which is basically work differently. TCP work differently and the UDP work differently. The in TCP, the data is break into data units, which called segment. In UDP, the data is also break, and that's called datagram. That thing is called datagram. So when we see that thing, then we discuss about that. But in TCP, what you have to remember that the message is break down into data units, and that data units is called segment. That data unit is called segment. Now what happened after that? These data unit are go towards the internet. These data segment goes towards the internet. These data segment are sent to internet. Now these data units internet send these data units to the sender. What it do? It send this data unit to the sender. It send this data unit to the sender. Okay, so this is how TCP basically work. Okay, so this is in a very simple way the TCP work like that. Okay, so we see in detail that how it break into data units, how it break into segment, then how it send to the internet, then how internet send back this data to the receiver, not send the receiver. Okay, so how that data from the how basically the data units come from the internet to the sender. So we see that thing that every layer in this case basically what happened is every layer work accordingly, means the data unit, who break the data unit, who send the data unit to the internet, then how internet back the data unit. So everything we see but this is the overview, this is the summary, like, okay, that how TCP work. TCP send the data. TCP basically break the message into some segments. That segment goes to the internet, and then it goes to the receiver end. Okay, so this is the basic overview. Now, one thing that you need to remember is that TCP break the data into segments. Okay, TCP break the data into segments. Now, after that, what basically we have to understand is that we see the basic difference between TCP and UDP. Transmission control protocol and user datagram protocol. We have to see that why generally TCP is more important than UDP, why TCP protocol is used rather than UDP. Okay, we see that thing, then only we can able to understand TCP accurately, very accurately. Okay, so first of all, that TCP means the transmission control protocol, and TCP is highly reliable. TCP is highly reliable. What does that mean? That means we can trust TCP, that whatever the message we send, that message will not break, that message will perfectly received by the receiver. Whatever the message I send, that same message is received by the receiver. It is highly reliable, means there is a no interruption between the communication. Okay, and second thing is it is slow. It is slow as compared to UDP. Transmission control protocol is basically slow as compared to UDP. Now in UDP, what basically happen is UDP is less reliable. UDP is less reliable. And the second point is that UDP is fast as compared to TCP. UDP is fast as compared to TCP. So here you can see that UDP is fast, but then also we are not use UDP, we are using TCP. So what are the benefits that TCP provide? That's why most of the organizations is basically use that's why basically TCP is more used. Okay, so we see that thing, that what are the advantages, what are the types based TCP provide. Okay, so now understand that how TCP is basically work. Okay, so and one more thing, that what is the difference between TCP and OSI model. TCP is a implement based model, means in a simple way if I say that OSI is a theoretical based model, means if you want to understand the computer network, if you want to understand the computer network in detail, that how the data is basically transferred, then you have to study OSI model, that how basically the data is transferred from one point to another point, what are the what basically happen while transferring the data from the sender to the destination. In TCP, the all thing is implemented. This is an implemented model. This is an implemented model. OSI model is of theoretical and TCP is of implemented. Its TCP is an internet design, whereas OSI is used for research in a simple way. TCP is a internet design and OSI model is used for the research purposes. Used for research. Used for research. So I hope this thing is clear to you, that what is the difference between OSI and TCP. Now let's see that how TCP basically work. How TCP work. Okay, TCP slash IP. Okay, so TCP means transmission control protocol, whereas IP means internet protocol. Okay, they both work to they both help to send the data from the source to the destination. Okay, so now what happened is, here is first of all, in this case we have only 5 layers: application layer, then transport layer, then network layer, then data link layer, then we have physical layer. Okay, so this is how this is these are the 5 layer which is used to send the data from the source to the destination. Okay, from the sender to the receiver. Now what happen is, first of all, the message is in application layer. Message is in application layer. It goes to the transport layer. The flow is like this. Okay, from up to down, from up to down. First of all, message is an application layer, then transport layer work, then network layer, then data link layer, and then physical layer. Okay, and then physical layer. I not made message in a physical layer because physical layer is not do anything in the message. It basically send this message. It basically send this message to the receiver end. This is sender end and this is receiver end. Physical layer, what it does basically, it send this message to the receiver end, and simply same thing, same layer work, data link layer, network, transport, and the application layer. Now the message is in application layer. First of all, the message is in application layer. Now what happen after that? When message goes to the transport layer, it work on that message, and message will be, there is some task which perform in a transport layer, so message will become heavy. Then some task is performed in a network layer, some task is performed in a data link layer. So when your messages goes to the downward from application layer to the data link layer, your message will basically add up so many things. What are the things we discuss in a few minutes? So for now, your message will basically add some IP, some MAC address, so many things will add it in every layer. Okay. Then when it goes to the receiver, this message when goes to the receiver, which is a combination of all these layers, is basically now open up, basically open. Okay, now whatever the message in the data link layer, same message is in is in a receiver end. In network layer, it removes some part which added here. In transport layer, it removes something. In application layer, the final message will be there. So whatever the message in an application layer in a sender part is same in the receiver part. Okay. Now here you can see that the lot of thing is added, and here lot of thing is removed, and then message is able to send from the sender to the receiver. Now what are the things what basically the data link layer add to send the message to from the sender system to the receiver system? Now we see this thing, that how the transmission is work, okay. So first of all we have to understand that the data is transferred into various forms. For example, the data will be sent in a radio waves. The data will be sent in a radio wave. The data will be sent through light. But in this case, TCP case, the data is sent through Ethernet. In transmission TCP/IP, the data will send in the form of Ethernet. And the cable which is used to send the signal in the form of Ethernet is fiber optics. Fiber optical cable, or twisted pair cable. So many cables are used to send the data in the form of Ethernet. But the thing that you need to remember is the data is sent in the form of Ethernet. There is other thing as well, like fast Ethernet and the Giga Ethernet. We see basically if you want to send the data very fast, then we use fast Ethernet, and there is a very big amount of data, then Giga Internet. Simply they all are fast Internet. Okay, so for the fast Ethernet, twisted pair will be used. For the Giga Internet, fiber optical will be used. So these are the wire which basically used to send the data in the form of Ethernet basically. Okay, and the data is transferred in the form of Ethernet. That you need to remember. Now let's understand about the data link layer in transmission control protocol, data link layer, DLL, or a data link layer. Okay, so what is DLL basically? DLL is nothing, simply a message. DLL is what? DLL is a message, or that message is called Ethernet frame. Ethernet frame. Okay, so that thing you need to remember, that the message in a data link layer is called frame. Is called frame. Okay, this is a very important thing, that the message in Ethernet is in a form of frames. Okay, so now in DLL basically is of two types. First one is MAC and the second one is LLC. Now what is MAC? MAC is medium access control, medium access control, and LLC is logical link control. They both are very important to send the data from the sender to the receiver. Okay, so now let's see that how basically it works. So in MAC, first of all, we understand about the MAC. MAC means medium access. MAC means medium access control. So what basically going on in MAC is, MAC we have in the data. Data is not like the message only. Okay, data is consist of so many things. One thing is called header, MAC address, or a header. MAC header. One thing is called MAC header. Then your message, and other thing is called error check data. Error check data. Error check data. And this is called trailer, this is IP, and this is header. The MAC address is of 6-bit. MAC address is of 6-bit data, which is used to transfer messages. Okay, without the MAC address, without the IP address, without checking the errors, the message is not sent from the sender to the receiver. Okay, so MAC address is basically of 16-bit data encapsulation. It's basically used for the data encapsulation. Basically means the data is kept with these things. This is data encapsulation. Means the data is wrapped up with MAC address, or you can say header, IP, and trailer. Okay, so and these things are used to send the data from sender to the receiver. MAC address is of 16-bit of data. Okay, MAC address is of 16-bit of data. This is called data encapsulation, means consisting of these part. What is error check data? We see that thing, that how the data is basically checked. I say you that the TCP is a highly reliable. Why it is highly reliable? Because it checks the data at every point of time, whether it's sent to the receiver or not. So what are the things, or how basically it check? We see that thing. MAC address is of 16-bit of data, which is also used to identify the destination, and IPs are definitely the one thing which is used to identify the host, identify the sender and the receiver. Okay, so your message will add up with IP and some MAC address and the trailer. The other thing is called accessing the media, that how we encapsulate your message, then how we can access that message. Accessing the media. Accessing the media. So media will be accessed by CSMACD. With the help of CSMACD, we can able to access the data. Now what is CSMACD? CSMACD is carrier sense multiple axis collision detection. Collision detection. Carrier sends multiple access collision detection, which is used to access the media. Okay, which is basically used to access the media, which basically identify that the collision is occur or not. It basically detect the collision. It basically detect the collision. Collision in the sense, for example, if we have systems like this is a one node, another node, okay, and we have a bus which basically used to send data. Okay, now what happen is this is n1, n2 and n3. Okay, so n3 have a message, n2 have a message, and n1 have a message. Now what happen is node 1 send the message to for the node 2, node 3 send a message to node 2, and there is one more node 4, which also send the message to node 2. Now what happened in this case? N1 message, N2 message, N3 message. There are three message which goes to the N2, So what happened in this case? Collision occur. There are so many messages. So what happened in that case? In that case, collision will occur. So that's what CSMACD detect. It detect the collision and basically solve that collision. Simple. So I hope you understand that CSMACD. Okay. Collision detection. CD means collision detection. It basically detect the collision and then solve that collision. How we solve that collision? We see that thing. Now after that, what basically we have other thing is, this is what a medium access control is. Okay, so this is what a medium access control, how the data is basically sent. Okay, this is what a MAC is, medium access control. First of all, it encapsulates the data and then access the data in a particular point. And if there is a error, there is a collision, then it detects the collision with the help of CSMACD. Now the other thing is LLC, which is logical link control. LLC, which is logical link control. Now what is logical link control? So logical link control is of two types. It is first of all flow control, and the second is error control. We detect the error by MAC address. Okay, so with the help of CSMACD, which is a part of MAC, so we detect the collision. Now we have to solve this collision. Okay, we say that TCP is a very highly reliable. So reliable in the what sense? Reliable in a sense that whatever the collision take place, it remove that collision and send that data again. So that thing basically do by the flow control and the error control. Okay, so first of all, we see that what is flow control. What is flow control? Flow control basically restrict the amount of data. What it does, it restrict the amount of data. It restrict the amount of data. What does that mean? For example, there is a one node, or you can say sender and a receiver. Now sender is working with a speed of 20 Mbps. Sender work on a speed of 20 Mbps, means sender send the message. This is what message. Sender send a message with the speed of 20 Mbps per second. But the receiver will able to read or accept the message with the speed of 10 MB per second. 10 Mbps. It can only able to receive the message 10 Mbps, means the basically the difference of these two means the 10 Mbps which is sent 10 Mbps messages which is sent by the receiver is not get to the not get to the sorry. So the message, the 10 Mbps message which is sent from the receiver end is not collected by the from the sender end, not collected by the receiver end. So that 10 Mbps message is what is waste. So for that to not waste the messages, to not interrupt the messages, to not it basically not the messages are not collide, not collision occur. So what basically flow control do, it says to the sender, it says see that the okay, so the receiver end is of 10 working with a 10 Mbps, so it says sender that decrease your speed to 10 Mbps, decrease your speed to 10 Mbps. Now the sender send the message at a rate of 10 Mbps and receiver easily add that messages, receiver easily add the messages. Same with the opposite case as well. For example, if okay, so I just made the M means the message. Okay, so these all are 20 Mbps. When sender send the message at the speed of 20 Mbps, so this is what get by receiver, and this is the lost data. Okay, this is the lost data. Now when flow control see that there is a loss of data, so what basically flow control do, it's the receiver is check that the receiver is working with a 10 Mbps, so it decrease the speed of sender to send the message, and it simply make the balance between them. Similarly with the opposite case, for example, if it receive the data at a speed of 20 Mbps, it receive okay, so it receive the data at a speed of 20 Mbps and send the data at a speed of 10 Mbps. So again there is a no loss, in this case there is no loss, but there is a space between there is a space in a receiver end. So what receiver do now is it tell the sender to increase the speed, because there is a lot of more space, lot more it can easily get the 20 Mbps data. So what basically flow control do, it increase the speed of sender, because receiver end can easily able to collect the message with the 20 Mbps of speed. Okay, so this is what a flow control is, to increase and decrease the rate of sending the messages. If there is a less number of if receiver are not capable to collect the data at that speed, so it decrease the sender speed, and when it will, so it increase the sender speed. This is what a flow control is. Now the other thing is, now the other point is error control. Okay, error control. We see in a MAC address, so we see in a MAC that data is bind up with MAC header, IP, and the error check data. Now what basically the error control do, it check this error, it check the error in the messages, it check the error in the messages, it check the error in the messages. If there is an error occur, then it basically asks the sender to send the data again, to send the data again, and this is basically work with the help of ARQ, automatic repeat request. Means if data is not there, it asks the sender to resend that data. Simply automatic repeat request, automatic repeat request. Okay, so now we see that thing, that how it basically work. For example, this is sender and this is receiver, sender and the receiver. So what it does, when sender send the message, this is the message, sender send the message to the receiver, and sender send the message to the receiver end. By some, by any circumstances, the data will not able to go to the receiver end. The data is not able to go to the receiver end. For example, if there is 5 messages, okay, 3 message will successfully send to the receiver end, and one message is basically stop here, and one message is also waiting for wait to send to go to the receiver end. So what it does, when the message is not sent, then what receiver do is, receiver generate an ARQ and told the sender to send that particular data, and told the sender to send that particular data. For example, if fourth message is not sent by the sender, then what sender do is, sender send that fourth message. If again the message are unable to receive by the receiver end, then again receiver send ARQ to the sender, and sender again send that data. Sender send that data again and again whenever the receiver end acknowledge that the message is successfully received. Okay, so ARQ is basically ARQ is not sent from the receiver form. It basically receive to the sender, send the data again and again. Simple thing. Means if the data is not sent, if data is not received by the receiver, then it says to the sender to send the data again, in a simple way. Simple. Okay, so this is what an error control is. If an error occur while sending the data, then the sender have to send that data again. That's why it is highly reliable. If one message is not there, then sender send that message again. That not take place in a UDP. That's why it's not reliable. Okay, there are so many things that why UDP is not reliable, and one of them is this, and that's why TCP is highly usable, highly reliable. Now, so these are the things. Now we are going to move to the network layer. Network layer. Okay, what basically we done only the data link layer, which is of two types: MAC address and a DLL, a MAC address and an LLC, medium access control and the logical link control. MAC is of MAC basically is a data encapsulation. MAC header is of 16-bit of address, which is used to detect the destination, and the message is added with some IP to get the address of a destination as well as the address of a sender. And error check is basically if the message is not sent, then it send that data again. It's the receiver told the sender that please send that data, and that thing will happen with the help of ARQ. And how we get that data is not sent, with the help of CSMA CD. If a collision take place, it notified, and then sender send that data. Okay, so we see CSMA CD in detail, and we see the questions of CSMA CD in the next videos. So now we are moving towards the next network layer. In data link layer, I write the message and IP. Means message with IP. Now that thing is used in a network layer to detect the destination. Now how the data is sent to the destination? If sender have the address of a destination, then only it can able to send the data. If you are going to someone place, for example, if you are going for in someone house, if this is you, if you are going for to someone else, if you not have an address, then how you can able to go, how you are able to go that place? Okay, so it's very difficult or impossible that you are not able to go that place. So that same thing is taking place in the network layer as well. If sender have not the data of a destination, if sender does not have an address of a destination, then sender cannot send the data to the destination. Okay, so And what the address of a destination is in the form of IP address. Internet protocol address plus message. When you have this collection, then now the network layer work. Network layer basically detect the address and send that data from the sender to the receiver. Okay, so this is called, and this is called IP packet. IP packet is what? The pair of, or the collection of message and the IP addresses. Okay, and the message is in the form of UDP or TCP. UDP or TCP. If it is a form of UDP, then it is called a datagram, and in the form, and if it is in a TCP form, then it is called segment. This is an important thing. That's why I told you again and again. Okay. Now let's see that how the sender send the data. Okay, so we have a okay, so we have a network. Network 1, router, network 2. Okay, so we have network 1 and the network 2. Now the what is the function of basically network layer is to collect the logical address, or to do routing, or to do the path discrimination. Okay, this thing, first of all we understand that what is the function of network layer is. What is the function of network layer is? The function of network layer is to find the logical address. Logical address means IP address. IP address to find the destination. Second thing is routing, and the third thing is path determination. We see all of these three things. Okay, these three things are important while sending the data from the sender to the receiver. Okay, so we see that thing. Now what we have to do is, let's see that how the things basically work. If you have a sender, if this is a sender and this is receiver, now sender what basically have is IP address plus the message in the form of segment plus message. This is called IP packet. So what it do, the sender send the IP packet to the network. For example, this is the network. The sender send the IP packet to the network. Network check the IP address, and whatever the destination address is, IP address is basically not only the destination address. IP address is of IP address of sender and IP address of receiver. So it check the receiver address and send that IP packet to that receiver. So IP packet is now in a receiver end. What it do, it basically take the messages, what message is there. So this is how the network layer works. Okay, this is how basically the network layer works. Okay. Now what happen if this is the sender and this is the receiver? Okay, and we have network 1, and that network is basically okay. So we see this thing, that how it works. Now we have a router and we have a network 2 and we have a the destination, or we write it like destination. Okay, destination, source, or you can say starting point, or source or destination. Okay. In above case we have only one network, so it is easy to send the data. In above case, we have only one network, then it is easy to detect the address of a receiver, and as well as it basically easy to detect where the receiver is in a simple way. And when we have more than one network, then how we can able to detect? Then how we can able to detect the destination? So for that thing, routing is used. For that, to solve this issue, routing is basically routing is not needed of the source and destination are in a same network. Means if the network is same where the source and destination are taking place, then routing is not needed. But if the network is different, then routing is needed. Then routing is needed. Okay. In routing, we have a term which is ARP, which basically detect the MAC addresses. Now we have one more thing. When there is a one network, then easy to detect. But IP packet is with, if IP packet plus the MAC address of source and the MAC address of destination form, this is called Ethernet frame. This is called Ethernet frame. IP packet, which consists of IP addresses and the data, and MAC address plus MAC address of source and destination, is called Ethernet frame. It's called Ethernet frame. For example, now let's see that if we have point A and point B present in a same network, A send the Ethernet frame to the network, and the network send the Ethernet from the network to the destination. Simple. Okay. So how it detect that? First of all, the IP address of A and the IP address of B plus the message. This is called the IP packet. If it contain of MAC address of A and the MAC address of B, then it is called Ethernet frame. And with the help of these things, it can detect the destination. It detect the destination. And how it detect the destination? ARP. With the help of ARP, it detect the destination. Okay. So when routing is basically not needed if the source and destination are in a same network, means ARP is not needed. If source and destination is are on same network, routing is not needed. Routing means the router is not needed. There is no router here, so router is not needed to send the data from the source to the destination. But when we have a different two network, in this case when we have two network, this is router. Routing is what? Routing basically a process to sending the data from the source to the destination. Okay. If you are using router for that, then it's basically routing. Nothing. Now in this case, when we have two network, then how the data is basically sent? Let's see that thing. Source have Ethernet frame which have IP address of the destination, IP address of, let's give it name A and give it name B. Destination and source. Now source have IP address of B and the IP address of A plus the message and the MAC address of a receiver or A. Oh, sorry. MAC address of R and the MAC address of A. MAC address of R and a MAC address of A. If I write a B, then the message is not sent to the B point. Why? MAC address of B is not in a same net. If it check, first of all, it check in the same network, that in network 1 there is a B, there is a destination point, there is a destination point which match this IP, which match this MAC address. So the answer is no. So what we are going to do is we are sending this Ethernet frame. What we are going to do is we are sending this Ethernet frame to the router. We sending this Ethernet frame to the network, and network send it to the router. Okay. We send this Ethernet frame from the source to the network, and the network send this to the router. Now router have IP address of B, IP address of A. Remember this thing, IP address of the source and destination are not changed. If you change IP address, it means you change the destination. So remember one thing, IP address of B is there in the source, but the MAC address is not there because it's not in a same network. Okay, so there is a one question in a GATE exam as well, in a form of an MCQ, that it changed the IP address of a destination, and I think it's asked that is true or not. So like that question. So IP address of the destination will never change. Okay, plus the message. And now what router do? Now router is a connection with the network 2. Router is having a connection with the network 2, and in the network 2 we have a destination. In network 2 we have a destination. So network 2 have a MAC address of destination. Network, without having a MAC address, we cannot send the data to the destination. MAC address and IP address both is needed to send the data. Now router, what it do, it take the MAC address of B from the network, and what the other thing is MAC address of. Now what router do is, router take the MAC address of B from the network 2, and now that this Ethernet frame is completed, and send the frame to the network, and network check the IP address, and now send that to this thing. Now send that to the destination. Now the Ethernet frame is in the destination. IPB, IPA, message, MAC of B, and the MAC of A. So I think this concept is clear. The concept of networking is clear. If both source and destination is in a same network, then routing is not needed, means router is not needed. If it is in another network, if network 1 have a source and a network 2 have a destination, then router is needed to connect the network, because we need a MAC address to send the data. And what it does is, network 1 or a source send the data to the router. Router change the MAC address to the destination address and give it to the network 2, and network 2 is basically to the destination. So I hope you understand this thing. This is what a network is. ARP is what? ARP is basically a module, does not provide any MAC address of a destination because it's another network. Means what ARPs do? ARP is basically a module which used to get the MAC address. Simple. Without MAC address you cannot send the data. Without IP address you cannot send the data. That thing will be arranged by the ARP. Okay, so what ARP do? ARP collect the router MAC address and write it in an Ethernet frame, and write it in an Ethernet frame and send that to the router. Now the ARP of network 2 will collect the MAC address of a destination 2, because in this network the MAC address of the destination is there. In this network the MAC address of source is there. So what ARP do? ARP collect that MAC address and change the MAC address with a router address. Initially it is R, then after collecting the destination MAC address, it B, and now it's sent to the network 2, and the network 2 to the destination. This is how the thing works. Okay, so I hope it's easy. to understand this thing. Now the other thing is called path determination. Path determination. Path determination. Now what is a path determination? We have a lot of server, 1 2 3 4. Okay, so there are numerous server, and this is source, and this is the destination. So this is source, this is destination. Now routers are there. So, and this is connected to the server as well. Server is interconnected to each other. Now what happen is, what is basically the path detection is, path detection is used to find the path that will be to find the perfect path to share the resources. There are numerous paths to send the data from the sender to the receiver. Okay, there are so many ways. For example, this is the house that you want to go. Okay, so there are so many ways, like if you go straight, if you go in a very long way, if you take a very long way. So there are numerous ways to go to that house, to go to your house. But the best way is what? This one, the straight, the displacement. This is what a best path is. Similar way in this case, path determination is used to find the shortest path to share the resources. This is your shortest path, and all the paths are basically very long. So you choose this path obviously to reach your home. Similar way, the source choose the source. What it does, the source choose that path which is shortest. The source choose that path which is shortest to send the resources. This is what a path determination is. Find shortest path to share resources. Find shortest path to share the resources. So I hope this path determination is also clear to you. Okay, so we completed the two layers. The data link layer, network layer, okay, and physical layer as well, because physical layer is nothing, simply to transferring the data from the sender to the receiver. Now the other thing is called transport layer. The next thing is called transport layer. Next layer is called transport layer. Now what is transport layer? Transport layer is nothing, simply transporting the data, transporting the segment from the source to the destination. Okay, so this is what the transport layer do. Network layer connect the network. Now who send the data from the source to the destination? The transport layer. Okay, now what data link layer do? Data link layer basically write all the addresses. Network layer make the connections. Transport layer transferring the data. This is how the things this is how the things is basically connected. This is how the layer is basically connected. It select one protocol. First of all, the transport layer, what it does, it select the one protocol. We have two protocol, UDP, TCP. We see the difference in the next videos, in the upcoming videos. Okay, so again the same thing, the data in the TCP is called segment, and UDP is called a datagram. Okay, first of all, transport layer, what it does, it select the one type, it select the one thing. Okay, so we see the basic difference, that how the transport layer work in TCP as compared to UDP. Okay, let's see this thing. So in TCP it supports segmentation, whereas UDP does not support the segmentation. Simple point first of all. TCP segmentation means okay, so what basically means the segmentation is breakdown of a messages. Segmentation means breakdown. Okay, so it support segmentation. And what segmentation is? What segmentation is? Breakdown of messages, and it does not support segmentation. It does not support segmentation, it support the segmentation. Okay, so what basically TCP does, TCP break down the messages. What does the mean of break down the messages? Like for example, this is our message. Okay, so this is our message. So what TCP do, TCP break this message in segments. So for example, this is one segment, this is two segment, this is three segment. Okay, so what TCP does, TCP break down into segment. Okay, so this message is divided into segments. This message is divided into segment, and these segment are received by the receiver, and then receiver add these segment and simply get the message. Okay, what in UDP does is, in TCP it's 100% sure that whatever the message is sent by the sender is total that message is received by the receiver. There is no loss of data. Okay, that's why TCP is reliable. What in UDP do is, we have the message, this message is divided into datagram. So this message divided into datagrams. For example, 1, 2 and 3, this is 1, 2, and one part of this datagram is missing. One part of this datagram is missing. Okay, this one is missing, or this one is lost. So that's why UDP is not reliable, because here in UDP the datagram is lost while traveling from a sender to the receiver by any error. Some part, some datagram is lost in UDP. Okay, so that's why it's not reliable, and TCP is reliable. So I hope you understand that why it is unreliable and it is reliable. After that, what's the other point is, what in TCP does is, basically in TCP what happen is, first of all, it basically follow the COS, connection oriented service. It follow COS, and UDP does not follow COS. COS means connection oriented services. What basically happen in this is, first of all, the connection established between the sender and the user. The connection will be established first of all. Then what happen after establish the connection? Then the data is transferred from the sender to the receiver. So means data transferring. And the third one, after transferring all the data, what basically have to do is break the connection, means the connection termination. Okay, so now the connection is terminated. So this is how TCP work: establish the connection, transferring the data, and the connection termination. What basically in UDP does is, how basically UDP send the data. In UDP there is no error checking, which is in which basically in TCP what happens in data link layer is check the error as well. In UDP does not check the error. Whatever the data is come, the same data is go, the some data is lost, some data the sender, sorry, the receiver not acknowledge the sender that this data is not there. Okay, it means that we have sender and we have receiver. Some message is transferring from the sender to the receiver, but the receiver does not acknowledge does not send the acknowledgement to the sender that this particular data is not received. Okay, this thing is happening to TCP, not in UDP. So that's why some data is lost, and sometimes some error occur, so it's not send that particular data. So that's why UDP is not reliable, and this is what happened in UDP. So these all things are happen, and these all things are not happen in TCP. TCP first of all establish the connection, then checking MAC address and IP, then basically it frame the IP segment, then Ethernet frame, then that Ethernet frame sent to the particular destination. So there is a lot of connections, there is lot of things basically TCP do to send the data, so that the exact data is sent from the sender to the receiver. This thing is not happen in UDP, so that's why UDP is fast as compared to TCP, and TCP is slow as compared to the UDP. So okay, so here is what lack of error checking, and it is fast as compared to the UDP. As compared to the UDP, it is fast. Okay, because here there is no checking of, there is not any kind of checking, means the data is correct or not, if the data is 100% sent or not. So there is no anything like that in UDP, so that's why it's fast. Whatever it sent, data is lost no matter, the final message is sent to the receiver. Okay, so that's why it's fast as compared to TCP, and that's why it's unreliable as well, and TCP is reliable. Now I write the COS, connection oriented services, or how basically it work. Let's see this thing, and then we are moving towards the next. So in a basic way, what is how basically COS work means how the connection established, so we have a transport layer, and first of all what happen is transport layer connect the transport layer basically connect the client and the server, means the source and the destination. What transport layer does, transport layer connect the client and the server, source or a destination, whatever you say. What it does, it first of all make the connection. Okay, so this is our first step, the connection request. This is our first step. Okay, now after making the connection, what it does, a request for the connection to B, then what we do is we send the acknowledgement to A that okay, I accept your request, and we now connect the make the connection between the client and the server. Now what A do is A again send the acknowledgement to B that okay, establish the connection. First of all what it do, A send the connection request, B accept the connection request, so it acknowledged, and then A again acknowledge that okay, this one was the final decision. So here the three what basically do is one for the connection request, another for the two for the acknowledgement. So three movement were taking place to establish the connection. Okay, so this thing is called three-way TCP connection handshake. What we say, that three-way connection or three-way TCP connection handshake. So I hope you understand this thing, that what the meaning of three-way connection TCP connection handshake means: connection request, accept, and the final acceptance by A. by the client. You can write it like client and the server. So I hope it understandable what is three-way TCP connection and how the connection is basically established. Okay. Now we are moving towards the next thing. This is what this is how the connection is established. Now, what basically during the data transferring. Okay, so during the data transfer, there is not only the one step which is taking place. There are a lot of steps, lot of types, lot of features which TCP offer, so that there is a best way to send the message perfectly. Okay, so what are the features that TCP gives? What are the features that TCP gives? Now understand these features. So first of all, what are the features is, first of all, is error free data transfer. What it is? Error free data transfer. Now, what mean by error free data transfer? Error free data transfer means whatever the data is sent by the sender, that exact data is received by the receiver. For example, we have sender and we have receiver. We have sender and we have receiver. Now what basically, if sender want to send the data, then what first of all sender want to do is, sender want to make a TCP segment, means break down the messages, and then that message will be collected, then message and IP address and the MAC address, then make a Ethernet frame, and that frame will travel. Okay, so how we check the error? It says that the feature that is error free data transfer. Now how we check that there is no error in the Ethernet segment is it check by doing checksum. It check the address by the checksum. How we make TCP? When your message is collected by some IP, is collected by the IP, this is what we send to the this is what we have, and with the help of MAC address of sender and the receiver, we send that data. The main thing is what? This one, the message and the IP of the destination. So the IP, how it check that this message is correct, how the receiver check that this message is correct. So what we do is, there is a term which called checksum. Checksum calculate a value and add that value to the message. For example, the value like ABC, sender calculate the value. That value is called checksum, that added to the messages. Now the message is transferred to the receiver. Now what basically receiver get is the message and the checksum value. For example, if the checksum value is ABZ, so here you can see that checksum value is different. Here what sender send is ABC and what receiver get is ABZ. So of course this is not a message that sent by this sender. This is not that message. So what do is, this is how it check the error. In the message. It means this message is sent by the any other sender, not by this one. Okay, so if it's ABC, then now receiver accept this message. So this is how it check the error in the IP segment. Okay, so this is how it check the error. Okay, it first of all what it do, it find the checksum of that IP and add that checksum to the message. If the receiver and send that message to the receiver recheck that checksum value. How it recheck that checksum value? Receiver have that what basically the message have, what IP segment have. IP of A means IP of sender and IP of receiver. It calculate with these values. Now what receiver do is, receiver also calculate the checksum. means checksum is calculated by the two times, first one by the sender and then receiver. Receiver calculate the checksum. If the checksum value is different, then it says that this is not my message, and if the checksum value is same as the checksum value of sender, then it simply receive that message. Okay, so this is how error basically checked in the checked. So this is the feature which provided by the TCP. Okay, so if the if and now what basically happen is, if this IP is not matched, then what receiver do is receiver acknowledge that thing. Okay, so receiver acknowledge that thing. If if the message is correct, then receiver acknowledge. If the message is not correct, means message is not received, then receiver does not acknowledge. It means sender have to send that message again. Okay, so this is how error free data transfer is happen in TCP. So we done error free data. Now the second feature that TCP provide is order data transfer. Order data transfer. The next feature is order data transfer. Now what does that mean? That means whatever in order the sender send the data, the same order receiver receive the data. For example, if this is what sender is and this is what a receiver is. So what sender do is, sender have a message and that message basically sent to the receiver. Okay, so what sender do is what the layer in the sender do is break this messages in form. For example, let's say it break the message in this way. Okay. And so it break the message in that part. This is order 1, this is 2, and this is 3. Okay, so these are the three order, or this called data segment. So if sender send in an order, like for example, first of all it send the 1, then 2, and then 3, then receiver receive in the same order. First of all, the order number 1 message will get, and then order number 2 message will get, and then order number 3 will get. 1, 2, 3, and then this message will combine, and this was read by the reader. Okay, so this is what the meaning of order data transfer means. The message is divided into data segments, and in whatever order the data segment is sent by the sender, in the same order the message will be received by the receiver. So this is what an order data transfer is. Okay, so it's very simple. Now the other feature that provided by the TCP is retransmitting of data. Retransmitting of data. What is it? Retransmitting of data. What does mean of retransmitting of data? If sender not received a message, then what? When the receiver not received the message, then it tell the sender to send that message again in a sim. This is what a retransmitting of data. If receiver not get a message, then sender send that same message again. Okay, this is sender, receiver. Okay, sender and the receiver. Now what it do, if sender, this is the message, and sender what do, it send the message to the receiver. It's sending the message, so many messages, so many data segment it sent to the receiver. Okay, this is A and this is B, for example. So message is sent from A to B, and what R acknowledge A, or what B does, B acknowledge A. Acknowledge means it simply, okay, so this is one message sent by A and it received by B. So what B do is B send the acknowledge to the A that yes, I get this message. Okay, and when the receiver not acknowledged to the source, not acknowledged to A, then what A does is A send that message again. It means A retransmitting the data again. If the receiver, if B acknowledge source, acknowledge A, then A not transmitting the same data, it transmitting the other data. What B says is yes, I get the message, now transmit the other message. If B does not send the acknowledgement, it means A have to send the same message again. This is called the retransmitting of data. Okay, so acknowledgement is not given by the receiver, then the sender have to send the message again, then sender have to retransmit the data again. Okay, so I hope this is also clear. Now the next feature is discarding duplicate pockets. Okay, so discarding duplicate pockets. So by its name it is clear that discarding duplicate pockets means if the same data is if the same data segment is received by the receiver, then it discard that same message. It means it terminate that same message, it not accept the same message. For example, okay, for example, this is A and this is B. This is A and this is B. A a source and B is a destination. Okay, discarding same messages. Discarding same message. Now what does that mean? If A send a message, okay, so A send a message to B. Okay, so first of all, message is divided into data segments. Okay, so this is the type of a message that sent by the A. So let's name them 1, 2 and 3. 1, 2 and 3. Now what basically happen is, if A send one data segment to B, A send one data segment to B, and A again send the same data segment, means 1, and rest of the message is same. This is the 2 and 3 data segment. But what A does is A transmitted the same data segment. These both are same. If the source send the same data segment, then what B do is, what the receiver do is, receiver discard the one same message. Now what basically the receiver have is 1 data segment, 2 data segment and 3 data segment. Okay, so if the duplicate data segment is sent by the sender, we not received that duplicate data segment, it terminate, it discard that duplicate message. So this is what discarding the same message means. Okay, so I hope this is also clear to you that what's the meaning of discarding the same messages. Now after that we have another feature which is called conjugation throw on a flow. Congestion throttling or flow control. Congestion throttling or flow control. Now what does that means? What does that means is, that means this is the sender and this is the receiver. Sender and the receiver. Sender, okay, so sender send the message. Sender send the message. If the receiver does not acknowledge, if the receiver does not acknowledge within a time limit, take an example, like for example it's a 30 seconds. Okay, so 30, 29, 28 till 0. If the receiver does not acknowledge to the source, then what the source does, source again send the same message. So I hope it is clear to you that what meaning of a flow control or congestion throttling. So I hope it is clear to you that if the receiver does not acknowledge to the source, if receiver does not acknowledge to the source, then what the source do, source again transmitting the same message. If the sender, if the receiver does not acknowledge within a time limit, then senders have to send the same message again. Okay, so I hope it is clear to you. So this is about the data transferring, and these are the features which provide by TCP to transferring the data. I hope it is clear to you. Now after that, so it's what I said, that it follow connection oriented services. We establish a connection, we transferring the data. Now the last step is for the connection termination. Now what it have to do is it have to terminate the connection. This is the transport layer connected with another transport layer. Now what we have to do is we have to break this connection. How to break this connection? We have a sender, we have a receiver, we have sender, we have receiver. Now sender say that work is finished. Now what R do is, R says, R given acknowledgement, yes, I collect all the data. Now R again says that my work is also finished. What the work of sender is? To send the message, it sent. Now it says that my work is finished. Now receiver said that yes, I collect all the data. Now receiver said that I simply extract all the data from the fragment. So it says that yes, my work is also finished. And what sender says, that sender acknowledge, okay, done. Now we have to break the connections. When both acknowledge for finishing their works, then the connection is now terminate, and this is called four-way handshaking. Four-way handshaking. This is called four-way handshaking. So I hope it is clear to you that what is four-way handshaking. It's very easy. Okay, so that's why TCP is basically reliable, because so many functionality is there. In UDP there is not that much functionality. It is fast, although it is not fast as compared to that, but it is more reliable. Whatever the sender send the message, that same message is received by the receiver, because so many protocols are there. So this is what the transport layer does. Okay, so we understand about the transport layer. Now we are moving towards the next layer, which is called application layer. Okay, now the fifth layer is application layer. Fifth layer is application layer. So what is the function of an application layer? Application layer basically used by the user to send the messages from the source to the destination. Okay, so it is used by the users to send the messages, to pass the messages from one computer to another computer, from source to the destination. So this is what the function of an application layer. I hope it is clear to you. So what are the examples of the application layers, like HTTP or HTTPS, okay, and Outlook. So there are different examples of application layer, but the one thing that we need to know is there are list of protocols that is used by the application layer. There are the list of protocol which is used by the application layer, or which is which basically implemented in this example, so that there is some protocol that how this thing work, how Outlook work, how mail work. Okay, so there are some protocol for some particular types, for particular for the particular program. So now we are seeing that what are the protocols that is used by these by these things. Okay, so the okay, so list of protocol. Now let's see that what are the protocols. First of all, it's a DNS. Okay, so yeah, okay. So first one is DNS. Now what is the meaning of a DNS? DNS means domain name system. DNS means domain name system. DNS means domain name system. What it do? It basically provide the domain to an IP address. It provide domain name to the IP address. Domain name to IP address, so that it basically it basically used to load that page. There are domain names. For example, you are using any website, so at last the last word is basically a domain name. So what DNS do? DNS provide domain name for a particular IDs, for particular IPs, so that it can easily accessible. In a short way, what DNS does, DNS is basically translate the DNS. What it does, it translate the IP to domain name. It translate the IP to domain name. The next the next protocol is DHCP. The next protocol is DHCP. Now what is DHCP? Dynamic host configuration protocol. Dynamic host configuration protocol. Dynamic name configuration protocol. Now what it does, it automatically assign the IP address to the protocol in a network. In a network, remember this thing. What it does, it assign the IP address to the protocol present in a network. What it does, it assigns the IP address to the protocol present in a network. This is what DHCP is. Now, after DHCP, we have FTP. We have FTP. Now, what is FTP? FTP is file transfer protocol. File transfer protocol. Now, what is file transfer protocol? By its name, it is clear that it is used to transfer the file over an internet. It is used to transfer files over a internet. Okay, file transfer protocol. Now, after file transfer protocol, we have thing which is called HTTP, hypertext transfer protocol. Hypertext transfer protocol. HTTP. Now, what it does? It is used to send and receive the web pages. It is used to send and receive the web pages. It is used to send and receive the web pages. Means what, whenever you load a page, so the first web page, the page which is load when you are simply open any website. If you are open google.com or anything, the first page you received is called a web page. Okay, so what it does, it basically used to send and receive the web pages. Well, if you are write HTTP, it means you are sending some web page or you are receiving some web page in an internet. Okay, so this is what HTTP is, hypertext transfer protocol. Okay, hypertext transfer protocol. Now, okay, so hypertext transfer protocol. Hypertext transfer protocol. Now, after HTTP, we have IMAP. IMAP. Okay, and IMAP, or we have IMAP and SMTP. IMAP and SMTP. IMAP means Internet Message Access Protocol. Internet Message Access Protocol. And what is the mean of SMTP? Means Simple Mail Transfer Protocol. Simple Mail Transfer Protocol. Now, why? What basically these two things do? So it is used to send email messages on an internet. It is used to send email messages on an internet. So used to send email messages on an internet. IMAP and SMTP, Internet Message Access Protocol and Simple Mail Transfer Protocol. There is a different in these two, but if I summarize these things, so these both are used to transfer the messages, email messages on an internet. Okay, so after that we have IRC. IRC means Internet Relay Chat Protocol. Internet Relay Chat Protocol. Internet Relay Chat Protocol. What it is used? It is used the internet chat. It is used for the internet chat. When you are simply chatting with somebody on an internet, then the thing which is the protocol which is used is IRC. The protocol which used is IRC, Internet Relay Chat Protocol. Okay, when chat on internet, when chat on internet, and the last we have POP. What is the meaning of POP? Post Office Protocol. Post Office Protocol. Now, what is a post office protocol? So a post office protocol is used by the email clients. Okay, remember this thing, that it is used by the email client to retrieve the messages from a remote server. Means if we have a different computers, so to get the message from the different servers or from a client, then we use POP, post office protocol. Okay, so used email chats to use email chats to retrieve messages from a different server or from a remote server. So POP is used, post office protocol. So these are the important list of protocol which in an application layer. So these are the list of protocols. So I hope these list of protocol are understandable. So we discuss all the 5 layers of TCP/IP. So this is all about that in this video. Thanks for watching this video.